Hello everyone, welcome to the course Animal Waste Management with the module name Special Waste Utilization, Week 3, Lecture number 4. The title for today's discussion is Biodynamic Fertilizer and Biofuels. Myself, Dr. Utkarsh Kumar Tripathi, Assistant Professor, Faculty of Veterinary Animal Sciences, Rajiv Gandhi South Campus, Banaras Hindu University. So today we are going to deal with two aspects. The first one is biodynamic farming and the second one is biofuels. If we see what biodynamic fertilizer or biodynamic farming is actually, so this is a holistic approach for accumulating, for congressing the plants, animals, soil health with the with the inclusion of mystic beliefs of Western culture basically. So originally it was a form of organic farming, and the rest biofuels, we all know that these are a form of renewable energy sources. The famous part of this biofuels, what we all know, is biodiesel, biogas and bioethanol. So what are the importance of sustainable practices in agriculture? Including these two things, sustainable agriculture practices such as those found in biodynamic farming and biofuels production are crucial for preserving ecosystems, enhancing soil health, ensuring food security for future generations. By minimizing chemical inputs and promoting biodiversity, those practices contribute to the resilience of agricultural system against climate change and resource depletion. If we see the biodynamic agriculture, we found that biodynamic fertilizer or biodynamic farming is a concept which is using the mystic or supernatural phenomena like lunar cycles, in which we are making the compost, we are making our cropping our plants and everything with the effect of, or you can say under the effect of lunar cycles. For example, here what we see that as the moon is increasing its size, in Hindi you might be knowing about Shukla Paksh and Krishna Paksh, with the increase in the size of lunar and going up to the full moon, we can plant some kind of seedlings which are having their fruits outside the ground, or you can say the above the ground. So when the moon size is increasing and going up to the full moon, then we are going cropping the plants which is having their fruits above the ground. And when the moon is reducing in size and going up to Amavasya, we are seeing it that we are getting a good bloom in the fruits which are lying below the ground. Here we can observe the things. So is there any scientific basis for that? We are not bit sure about the scientific validation of these concepts, but we can say that these are just beliefs of our Western world. The next, one more belief is there that if we are keeping making the compost inside the horns of cattle and putting it under the ground, then we can say that the whatever we are getting after few months, then this will be adding more microbes, more beneficial microbes in soil. So here in this way we are putting the compost inside the horns of the cattle and then buried into the ground, and thereafter when we are removing it outside and we are using in the farm or in the garden, then we are going comparatively better compost with the microbial load. So who started it? If we know about the progress of biodynamic agriculture, we find that biodynamic agriculture concept was put forward by Rudolf Steiner in year 1924. So this was all started by 8 lecture series by the Rudolf Steiner in back, which the person was actually a philosopher and the founder of anthroposophic agriculture, and later that anthroposophic agriculture later was known as biodynamic. So now right now we are knowing it, the concept of that biodynamic agriculture is with us. So that lecture was delivered by Rudolf Steiner in 1924. So in 1924 it was delivered, and thereafter there was establishment of a society of farmers which were interested in such kind of agriculture farming, and that is known as anthroposophical farmers, that was constituted in 1926, and thereafter in 2 years in 1928 biological and dynamic methods was got famous when it was translated into English. So up to 1938 that biodynamic methods of farming was in fashion thereafter, and this is nothing but actually a form of organic farming. So here we see that what is the basic principle of biodynamic fertilizer or biodynamic farming. We can say that it is just a holistic approach which is just making a group, or we can say that crop, animals, composting, and with the use of natural power and some natural forces. Means we are including all these factors for the betterment of the soil and betterment of the ecological balance and sustainability. So biodynamic fertilizer, organic fertilizer which is based on the biodynamic principle are emphasizing a sustainable and ecological approach to farming. They utilize locally sourced material, ensuring that the farm operates as a closed ecosystem. This system is often referred to as beyond organic, as it integrates with various elements of the farm. Here we see that there is just integration of plants, animals and soil, and that cohesive units promotes biodiversity and ecological balance. So here we are concerned about our biodiversity as well as ecological balance, and we are putting these factors like plant, animals and soil for the maintenance and for the sustainability of these things like biodiversity and ecological balance. So what is the use of that compost, manure and herbal preparation in biodynamic farming? That new concept of biodynamic practices prioritize the use of compost, animal manure and specific herbal preparations, which composting is crucial as transforms organic matter into nutrient rich soil amendments, which in turn enhance the soil fertility and microbial activity. So we see here that biodynamic preparations such as cow horn manure, for what we were discussing earlier, that cow horn manure which is coded in the form of BD500, we can say that biodynamic 500 or BD500, and horn silica like BD501 are used to stimulate the plant growth and improve soil health. These preparations are often made by fermenting a specific material in animal horns, which is believed to harness the cosmic force. Here you are observing it that we are talking about the harnessing of cosmic force, which is beneficial for the soil. So ultimately we know that this biodynamic agriculture is having its effect on soil health and ecosystem balance. So the core principle what we are observing here of this biodynamic agriculture is the health of the soil. So we are talking about the health of the soil. So we are approaching to restore and maintain soil vitality through practices that enhance its microbial activity. So ultimately we are going to enrich the soil health by putting our effort to increase the microbial load, microbial content of that beneficial bacteria and other microbes into the soil by incorporating such kind of thing like horn manure or horn silica, we can say, with the effect of cosmic power or lunar power or lunar cycle. So by focusing on composting, cover cropping and crop rotation, biodynamic farmers aims to create a balanced ecosystem that supports both plants and animal life. This holistic view fosters resilience against pest and disaster while promoting sustainable agriculture practices for future generations. So is this the actually holistic approach to agriculture? Yes, biodynamic farming views the farm as a self-contained organism. So here we see that biodynamic agriculture itself is observing the things as a self-contained organism, where every element like soil, plants, animals and humans interact and supports each other. So the holistic perspective encourages practices that enhance the natural relationship within the ecosystem, aiming for self-sufficiency and resilience. Farmers work to create a balanced environment that nurture biodiversity and foster a regenerative agriculture system. So moving beyond traditional organic method to include spiritual and cosmic consideration in farming practices. So what we are observing here, that in organic farming we see generally that all these methods are included, like composting, vermicomposting, what we have seen in our earlier discussions, that all these things are just observed in organic farming also. But what is different in this biodynamic farming? Here we see that there is involvement of some spiritual and cosmic consideration in farming practices. So this is actually the integration of crop, livestock and biodiversity. That is, a fundamental aspect of biodynamic farming is the integration of crops, livestock, which promotes the nutrient cycling and reduces dependency on external inputs. Means if we are incorporating all these things in our farming system, then certainly we are going to reduce our dependency on chemical fertilizer, so that we can cut down the cost incurred for those kind of chemical fertilizer and pesticide, chemical insecticide, all these things, and we are making a better world by using all these methods of agriculture. So this diversity not only improves soil health but also helps control pests and disease naturally. So biodynamic farms often set aside areas for biodiversity preservation, contributing to ecological equilibrium by supporting wildlife habitat and promoting a variety of crops. So we were talking again and again about the use of lunar cycle in planting and harvesting. So in previous picture we have also observed that how we can plant according to the concept of biodynamic agriculture. We can plant with the increase in lunar size or lunar shine, sunlit and totally omitted lunar system like in lunar cycle. So biodynamic farming incorporates lunar cycle into agriculture practices, believing that the phase of the moon influence plant growth. Farmers often follow a planting calendar that align with the lunar phase to optimize crop yield. For example, we can say that certain days are considered more favorable for planting specific crops or performing particular tasks based on the moon's position. This practice reflects a deep respect for the natural rhythm and cosmic forces. So here we can observe that farmers which are more inclined toward the natural rhythms and cosmic forces, they are relying more and more on biodynamic fertilizer. Means farmers are just planting, sowing their seeds or putting their plants inside the ground in their field, on depending upon the lunar cycle. If they want to plant some kind of plant which are having fruits above the ground, then they are trying to put their seeds inside the field in increasing size of the moon. Means, and if they are putting the plants, if they want to put the plant which is having their fruits, or you can say their yield, their harvest inside the ground, then they are supposed to put their seeds in darkened phase of lunar cycle. So this practice reflects the deep respect for natural rhythm. In summary, we can say that biodynamic farming is characterized by its holistic approach, integration of diverse agricultural elements and alignment with natural cycles, all aimed at fostering a sustainable regenerative agriculture system. So what are the benefits of biodynamic fertilizer? Here we see that biodynamic fertilizer offers several significant benefits that enhances soil health, promotes sustainable farming practices and chemical inputs. Here we see that biodynamic fertilizer actually improve the soil fertility and structure. Biodynamic fertilizer contribute to enhanced soil fertility. Means here soil fertility is increased by inclusion of biodynamic fertilizer methods. This process not only provides essential nutrients for plants but also improves soil structure, making it lighter and more aerated, which facilitate better water retention and root growth. So what we are observing here, that biodynamic fertilizer increase soil fertility, increase essential nutrient availability for the plants, the soil structure is also improvised, it became lighter, the soil became lighter and aerated. So the better growth of the roots is possible by applying these methods. The holistic practice in biodynamic farming aims to regenerate the soil, ensuring that it remains productive over time while also sequestering carbon. Means carbon sequestration, which is becoming a huge problem now. The basic cause responsible for that is the carbon load. So by applying that biodynamic agriculture or biodynamic farming, we can help to sequester the carbon. It's possible by applying these biodynamic agriculture methods. The use of biodynamic fertilizer is also fostering a diverse microbial ecosystem. Here we are seeing again that it is going to help our soil constituent, the soil microbes within the soil. So these fertilizers are rich in organic material that serves as food for the beneficial microorganisms, which in turn increase the microbial activity, leading to improved nutrient cycling, which essential minerals more bioavailable to plants. This biological richness enhance plant resilience against pest and disease, resulting in healthier crop. Additionally, we can say that biodynamic preparation is specifically designed to boost microbial diversity, support this dynamic ecosystem, promoting a balanced and thriving soil environment. It also reduces our dependency on chemical input. So here we can observe that when we are putting the yield of biodynamic fertilizer or biodynamic agriculture we are practicing, then we can reduce our dependency on chemical setup or chemical inputs or some outside inputs for our farm. So we can say that ultimately we are going to cut down the cost incurred for agriculture, for the crop production. So biodynamic fertilizer are actually essential component of biodynamic farming. So designed to enhance soil health, promote sustainable agriculture practice, and here we are having few examples of that biodynamic fertilizer. So the compost preparation, that BD500 with the code BD500 you can say, or this compost preparation are specifically formulated to enhance the composting process and improve soil fertility. One of the most notable is BD500, which is most famous part of that biodynamic fertilizer. Here you can see in this picture that how horns are buried inside the ground. That horns is actually filled up. That horns, you might be knowing, you all know that it is hollow structure. So these horns are filled up with compost, and these are, after filling with the compost, these horns are buried under the ground, and after a few days and up to months, these are just removed out, taken out, and thereafter the content in these horns, these cattle horns, can be used for gardening purpose or for agriculture purpose, for putting in plants, and this will be more helpful for making it more beneficial for microbial load. Beneficial microbes will be added more efficiently, more proliferation view, so that we can have better result out of our composting. This preparation stimulates soil microbes activity and enhances nutrient availability, promoting robust plant growth. Other compost preparation, which include BD502 and BD507, which utilizes various herbs to enrich the compost with specific beneficial properties, such as many of them improving nitrogen, many of them can improve phosphorus, and so on. So whether we are having some herbal preparation examples also, yeah, we are having various examples for that, like yarrow, which is denoted with code BD502. You might be knowing that BD is standing for that biodynamic. So BD502 means yarrow, that helps enhances adaptability and regulates potassium. So here we can say that yarrow is responsible for regulating that potassium metabolism in plants. If we talk about the chamomile, that chamomile which is denoted with BD503, which improves the nitrogen resistance in fertilizer. Nettle BD504, this nettle BD504 contributes the soil structure improvement. Dandelion BD506 with the code name 506, which promotes the nutrient absorption and strength in plant, which is having the ability to attract nutrient. So we see that there are very high number of herbal preparation which is involved, which is aggregated in case of dynamic agriculture. Now the manure based fertilizer we have used so far, that cow manure and some other animal manure. So rich in nitrogen, we all know that cow manure, and having multiple beneficial bacteria, which is often used to compost the heaps and kickstart the decomposition. Other animal manure, if we talk about, then we came to know that goat, chicken and horses manure are also utilized for their nutrient content, contributing to the overall fertility of the soil. Now, we are here to discuss about the biofuels. Biofuels, which is very well known term that are an essential component of the renewable energy landscape, which is derived from biological material. Here is an overview of their definition and types. If we talk about the biofuels in detail, then we know that biofuels are renewable energy source produced from biomass. So, the raw material for biofuels is biomass, which includes organic materials such as plants, animals, waste, microorganisms and other things. Unlike fossil fuels, which take millions of years, we know that petroleum, coals and other biofossils or fuels are taking a very long time. Like you can say that millions of years have been taken by those fossil fuels to make up in this form what we are using right now. But in comparison to that, biofuels are taking lesser time, less than a year to develop it, and we can use with equal efficiency as our fossil fuel. So, what are different types of biofuels? The first one is, and the most famous is bioethanol. Bioethanol, which is an alcoholic fuel which is primarily from fermenting the sugar found in crops such as corn and sugarcane. So here for making biofuels, the first example is bioethanol. Through bioethanol, from where we are getting that, we are just decomposing the sugar which is contained in the plant product like sugarcane, or we can say the sugarcane and maize, actually the corn. We are getting the product out of that crops. So it is commonly blended with the gasoline thereafter to enhance octane level and reduce emission. The fermentation process converts sugar into ethanol, means the fermentation is responsible for converting sugars into ethanol, which can then be distilled or refined to be used as a fuel. If we talk about the biodiesel, another important aspect of the biofuels, which is produced from vegetable oil and animal fats. So here we are having two components, the vegetable oils and animal fats or recycled cooking oil. So basically we are using the fat out of the plants or out of the animals. After processing of transesterification, that process known as transesterification, which produce biodiesel, ultimately it serves as a cleaner burning alternative to petroleum jelly. So biodiesel can also be used in its pure form, means B100 with the code name, or blended with conventional diesel B20, which contains around 20% biodiesel. If we talk about the biogas, what we have discussed so far in our previous lecture also regarding biogas, biogas is primarily composed of methane and carbon dioxide. So methane is the combustible part of that biogas, and that carbon dioxide is not combustible as such, but it is adding energy and carbon to the biogas, and is produced through the anaerobic digestion of organic matter such as animal manure and food waste. So ultimately what we are going to do, that we are supposed to dispose of our animal waste, our organic waste, our plant based byproduct, or we can say the waste of plant agriculture, so to make the biogas. So it can be used for heating, electricity generation or vehicle fuel after purification. So here we see that biofuels are again classified in form of first generation biofuel, second generation biofuel, third generation biofuel and fourth generation biofuel. So what are the actual difference between these biofuels? That the first generation biofuels are having high carbon content. I mean, carbon content is high in first generation biofuels, but it is actually obtained from the actual crop, means sugar crop and corn crop, which is having starch and sugar in pure form. While the second generation biofuels, the greenhouse gases content less than first generation biofuels, because it is not that much pure and it is prepared from the rice husk and wood chips. The third generation biofuels, it is carbon neutral, means CO2 emitted and CO2 sequestered is actually equals. So there will be no loss, no gain type, so producing using microorganisms like algae. The fourth generation biofuels, which is made from the genetically engineered crops, and it is actually carbon negatives. So sugar crop, if we talk about the actual procedure, how we are going to get bioethanol. So here we are having two aspects, that either we are using sugar crop or we are using starch crop. So after using sugar crops, we get after extraction the sugar, and thereafter after the action of the yeast on that sugar, the fermentation occurs, and that fermentation after distillation we get bioethanol. In case of a starch crop, what we are doing that after mechanical grinding of that starch crop, we get the starch, and thereafter with the action of alpha amylase enzyme we get it liquefied and 90 to 105 degrees Celsius, and thereafter with the action of amyloglucosidase and thereafter saccharification means the action of yeast, thereafter at 50 to 60 degrees Celsius again we undergo for the fermentation, and thereafter the procedure is same of that sugar crop and the starch crop. After fermentation and distillation we get bioethanol ultimately. So actually what we saw here that we are having three things: preparation of our plant products, and thereafter getting it fermentation, and thereafter distillation of that means, and thereafter we get either first generation bioethanol or second generation bioethanol. So first generation bioethanol, what we have gone through, that actually coming from the edible agriculture product like either sugar or corn. So this is cut to cut competition between the food and fuel in case of first generation bioethanol, and the second generation bioethanol is coming from the non-food biomass. Means here we are not actually using the food material which is meant to be provided for the humans. So we are not going to get involved in any kind of competition on the basis of food and fuel in case of second generation bioethanol. So biodiesel production process, again biodiesel, here we were using that animal fat, vegetable fat or some other fat like material either from the animal or agriculture byproduct. Thereafter the first process is having feedstock preparation. The vegetable oil or animal fat are first filtered and heated to remove impurities and water, ensuring that the feedstock is suitable for the transesterification. Here that bioethanol was the product of fermentation and the biodiesel is the product of transesterification reaction, because the fat is directly involved in this biodiesel preparation. And where in our previous things that bioethanol, the fermentation was occurred on sugar, either on sugar or on starch. So here we see that as directly fat is involved in this procedure, so the transesterification is taking place. So transesterification reaction, the prepared oil or fats are mixed with the alcohol and catalyst, and the reaction break down the triglyceride into fatty acid, methyl estearate, which is biodiesel, and glycerin byproduct. So now it's turn to separate the product obtained and then purification. After the reaction is complete, the mixture separated into two layers, the biodiesel, the upper layer, and the glycerin, the lower layer. The biodiesel is then purified through washing and drying process to remove any remaining impurities, alcohol or catalyst residues. So the final product, the purified biodiesel, can be used as renewable fuel for the diesel engine either in pure form like B100 and blended with conventional diesel like B20, what we have discussed earlier. So what are different feedstock for the biodiesel production? Here we know that we are not going to involve in any competition with the food and fuel in case of biodiesel production. So here we are using the jatropha or algae or rapeseed. So the jatropha, as we all know, that drought resistant plant that produces seed rich in oil. Jatropha is considered a promising feedstock due to its ability to grow on marginal land without competing with food crops, while algae, we all know that algae have a high oil content and can produce biodiesel efficiently. If we talk about the rapeseed, which is commonly used in Europe, rapeseed oil, that canola oil, is a popular feedstock for biodiesel production due to its favorable oil yield per hectare and established agricultural practices. So the environmental impact of biofuels, we know that if we are using the biofuels in our vehicles and for our other use, then we are tilting toward the carbon neutrality, means the carbon dioxide released during the combustion of biofuels is offset by the CO2 absorbed by the plant during their growth, so creating a closed carbon cycle. If we talk about the emission reduction, that studies indicate that bioethanol and biodiesel can reduce greenhouse gases emission by 30 to 80% compared to the gasoline and diesel, depending upon the feedstock and production method used. And life cycle analysis, if we go for, then we get that considering the entire life cycle from cultivation to production and use, the biofuels generally have a lower environmental impact than fossil fuel. So what are different potential for sustainable energy production? That we are here concerned with the two aspects. The first one is waste utilization and the second one is energy security. If we talk about the waste utilization, we get that many biofuels production process utilize agriculture and food waste. So ultimately what we are doing, that we are disposing our animal waste or agriculture waste in a better way, and thereafter we are again getting our energy needs fulfilled with the use of our waste. So we are getting ultimately the best out of our waste. So what are different economic benefits of biofuels? Here we see that if we talk about the economics, then the job which is created by use or growing or cropping up these biofuels related plants, that job creation in rural areas is very useful in fashion. Now agriculture employment, if we talk about, then increased demand for feedstock leads to more job in farming, harvesting and processing. Manufacturing and production of biofuels facility required skilled labor for production, maintenance and management, contributing to local economics and generating more and more job which is related with the biofuel production and processing. So what are different opportunities for farmers to diversify the income sources? Biofuels provide farmers with new avenues for income generation. It is also having the concept of value-added products. It is also responsible for sustainable practices. For engaging in biofuel production encourages the sustainable agriculture practices that can enhance soil health and long-term farm viability. So what are different challenges in biofuel production? The very first challenge in biofuel production is land use and the competition what we see in food and fuel. So we see that one of the primary challenges associated with the biofuel production is the competition for arable land between biofuel feedstock and food crops. As the demand for biofuel increases, there is a risk that agricultural land will be diverted from food production to grow energy crops. So either we go for direct land use change or indirect land use change, ultimately we are going to see the competition with the food crops. So impact on food prices and availability, if we are growing our biofuels crops in the farmer fields, then ultimately we are going to get involved in competition. So thereafter as a result the food price will be on hike just because of that land has been occupied for production of other things rather than crops. So increased food prices, we are a bit sure that this will happen if we are growing more and more biofuels, and higher prices can disproportionately affect low income population who spend a large share of their income on food. So food security concern, here we are that as more agricultural resources are allocated to biofuel production, there is a risk that food supply will not meet growing global demand. This situation can lead to food shortage and increased reliance on imports in some regions, further complicating food security issues. Thank you.